Okay, last time we talked about the tangent ratio. Today we're going to talk about applying the sine and cosine ratios. We're also throw in some tangent stuff as well. But basically, yesterday we didn't use any hypotenuse. Today we're going to use the hypotenuse, okay? So if you look here, you'll see that the sine is equal to the opposite over the hypotenuse, okay? Just like yesterday, tangent, which is down here, was equal to the hypotenuse. I'm sorry, tangent was equal to the opposite over the adjacent, okay? Today, you're going to learn that sine is equal to the opposite over the hypotenuse, and cosine is equal to the adjacent over the hypotenuse, okay? You'll hear a lot of people refer to this as SOHCAHTOA, and you know, there's a big backstory to SOHCAHTOA about some Indian chief or something. I'm not really sure what that means. I just remember that SOHCAHTOA, that's kind of how it spells out. You know, S-O-H, SOHCAH, C-A-H, TOA, T-O-A, and that's kind of how I remember what goes with what. I know that Miss Wilson had something that she used last year that said something like some old hippie caught another old hippie, or some old hippie, sorry, caught another hippie tripping on acid. Okay, I just didn't really want to throw out there the drug thing or whatever. So, but that's another way. You can think of any kind of anagram or whatever you want to come up with your own way to remember that sine equals the opposite over hypotenuse, cosine equals the adjacent over hypotenuse, and tangent, of course, like we learned yesterday, is the opposite over adjacent. Again, very much like some of the stuff in 7.3 and 7.2, 3, and 4, you're going to have to memorize that. You're going to have to know this and not get them confused. And that's the hard part, is just keeping them straight as you memorize them. Okay? Let's go ahead and put those into action. Say if we have our standard triangle here, we have A, B, and C. This is a right triangle. Okay, it's what we're dealing with primarily is the right triangle. Okay, if A is opposite, if we're talking about getting the sine of A, that's our emphasis on this particular problem. You see that the opposite of A is that lowercase a. So to find the opposite over the hypotenuse is C. So that's how you get sine of A is A over C. If I'm looking for the cosine of A, I'm now going to do the adjacent, which is over here. The one, again, adjacent just means next to the angle, okay, or attached to the angle. That's going to be your B over your hypotenuse, so B over C. And then, of course, your tangent, which we learned yesterday, just to review a little bit, is your opposite, A, over your adjacent, B. Okay, and that's all relative to angle A. If you wanted to do angle B, so if you wanted to find the sine of angle B, the opposite of B would be little b over the hypotenuse, which is C. Cosine of angle B would be the adjacent, which now becomes A, okay, over C, which is the hypotenuse, and then finally tangent of angle B is equal to the opposite again, which is A. Sorry, that's the wrong arrow. Which is little b, not A. So opposite over, which is B, opposite over adjacent, which in this case is A. And again, the way you find sine, cosine, and tangent is simply putting into opposite over hypotenuse, opposite over adjacent, and then adjacent over hypotenuse, but it's all relative to the angle that you're using. Okay? The opposite angle, the opposite side is always the one that's across from the angle. The adjacent is the one next to it. Okay? All right, let's look at another example. Let's go ahead and put this into action. If I wanted to find the sine of angle A for this triangle here, I need to take, again, for review, I want opposite over hypotenuse, okay, which is going to be, of angle A, the opposite is going to be 4 over the hypotenuse, which is 5. And again, if I get my four place decimal, I'm going to have 0.8000. My pen is not working. Okay. If I want the cosine is going to be my adjacent. And so that's going to be the angle right next to A. So my adjacent over my hypotenuse. So the adjacent side is 3 over my hypotenuse is 5. Which is going to give me 0.6000. Okay? And then if I want my tangent of angle A, my tangent, again, if you remember, is the opposite over adjacent. So again, the opposite is 4 over my adjacent in this case, which is 3, which will give me 1.333. Okay. Why don't you go ahead and pause the video for just a second. I want you to find the sine, cosine, and tangent of angle B. All right, we're back. Hopefully you pause the video and you're going to get the answers. Let's go ahead and go over this. Okay, the sine of B is your opposite. So the opposite of B is 3 over your hypotenuse, which is 5, which is going to equal 0.600. Cosine of B, this time it's the adjacent over the hypotenuse, so it's going to be 4 over 5, which is going to equal 0.8000. And last but not least, you have your tangent, which again is your opposite, okay, over your adjacent this time, so 3 over 4, which will give you 0.75000. Okay? Notice that the sine of A, okay, the sine of A is the same thing as the cosine of B. Just like the cosine of A is the sine of B. Why do you think that is? Yeah, it's because they're complementary. That's exactly why it is, because they're complementary because, again, you have your 90-degree angle, which is C here, but A and B both equal 90 degrees together. So they're complementary, and so what's going to happen is the sine of one is going to be the cosine of the other. Okay? And it's going to work like that every time. All right, let's look at our next example. Before we get into that, I'm just going to remind you how to use a calculator. Using the calculator is the same as the tangent. Make sure you're in degree mode. It's very important that you're in degree mode. Second period is going to have to especially pay attention because of having to follow an Algebra 1 class. If you're given an angle measure, on your calculator you're going to hit the sine or cosine, whatever you're looking for, and then type in the angle measure. Hit enter. And then voila, there's your answer. Some random decimal. Okay? If you want to find the angle measure, in this case you have to hit second. So you can get the inverse. You're going to hit the sine or cosine button again, whichever one you want. And you'll have that inverse of sine. You're going to plug in the random decimal you have or the fraction you have. Hit enter. And voila, you have your answer, an angle degree measure. Okay? One thing I do want to clarify on this, when you do these, if you end up with an answer like on your homework, some of you might have gotten this, 9.999, some other random decimal, then you can just go ahead and assume that's 10. Okay? Or just like if you get 10.000 and then some number, you can assume that's 10 as well. Okay? But always keeping 4 decimals for your tangent, sine, and cosine. All right, so let's solve for r. Okay, if I want to solve for r, let's go ahead and approach this. I'm given an angle measure of 43. Because I'm dealing with the right angle, I can also figure out that the other angle measure is 47. But I don't necessarily need to do that. So if I want to find angle R, and I want to use the given information only, I would set this up and say, okay, what is R? How does R relate to my angle measure? Well, it's the opposite. Okay, so I can do either, right now I can do sine, which is opposite over hypotenuse. Okay, or I can do tangent, which is opposite over adjacent. Now here's the problem. My adjacent side is S. So that's not going to help us figure out the actual answer. So what I need to do then is I'm going to go ahead and use the hypotenuse because that's given. So now I can say sine, the sine of 43 is equal to R over 26. Okay, and I can work that out. I multiply both sides by 26. These are going to cancel. That's going to leave me with R. And then I have 26 times the sine of 43. I can plug that into my calculator as long as I use the correct numbers and everything. Okay, but I can also just do 26. I can go into my calculator and hit sine 43 and get a decimal, which is roughly 0.6820. And I multiply those together times 26, and I end up with R is 17.73. Okay, and again, I'm just rounding to the nearest hundredth there. You just kind of have to follow the directions on the homework or the test, whatever's given to you. Okay? And again, if you round early, so if you take that, if you do sine of 43 in your calculator and just keep it like that, and if you plug this in right here, if you plug that straight into your calculator like that, you might have a slightly different answer, maybe off by a tenth or so, because the calculator won't approximate that right away. But if you approximate early in the problem, you may be off just a very little bit, but it's not going to hurt. You know, you'll be able to figure out the answer, and we won't count it against you, as long as it's not too crazy. Okay. All right, let's look at another example. I want to solve for S now, and again, I want to use primarily the given information. So I have an angle of the same thing, same triangle. Okay, angle of 43. I'm solving for S now. So now I have the S being the adjacent angle, so I can do a couple things. I could do cosine of 43 equals adjacent over hypotenuse, or I could do tangent of 43 equals opposite over adjacent. But again here, the only reason we have R is because we just solved it. I don't want to use R because if I screwed up on R for any reason, that means I'm automatically going to mess up on S. So I'm going to use only the given information, so that's going to eliminate the tangent. So what I'm going to do is I'm going to do the cosine of 43 is equal to the adjacent, which is S, over the hypotenuse, which is 26. Okay, now I'm going to, just like the last problem, multiply both sides by 26. These are going to cancel out, leaving me with S over here. And again, you can hit in your calculator cosine 43, enter, and you're going to end up with something like 26 times 0.7314. Okay, and then you multiply that by 26, and you end up with 19.02 equals S. And again, it depends on where you approximate, but that should be your answer. And this activity in this section is very similar to the section that you did yesterday with tangent. Now we're just using two other trig functions or trig ratios. Okay, if you have any questions, as always, please come see me in tutoring. Write them down. Also, don't forget you have about 9 days until your project is due. You also have a retest on Friday you need to be studying for. A lot of stuff going on right now. We put ourselves in a bind a little bit, so now we need to dig out. So you're going to have to put a lot of effort into math over the next few days. Okay? If you have any questions, come see me. Otherwise, have a great night.